You've walked past them 1,000 times without ever questioning them. They're just rocks. Dirty, ugly, gray rocks sitting beneath some of the most powerful machines ever built. But what if I told you those rocks are one of the smartest engineering decisions in history, and that they connect your morning commute to ancient sailors crossing the open sea? Next time you're standing at a train station or watching a locomotive thunder past a crossing, look down. Beneath those massive steel rails and heavy wooden ties, you'll always find the same thing: stones. Millions of them. Rough, gray, jagged stones stretching out for thousands of miles. It doesn't matter if you're in India, the UK, or the United States, the stones are always there. But here's the question nobody ever thinks to ask. Why do we rest our most advanced high-speed trains on a loose pile of rocks? Why don't we just bolt the tracks to a solid concrete road? The answer isn't just about saving money. It's a brilliant piece of engineering that stops trains from slowly sinking into the earth, and it hides a surprising history that connects modern railways to ancient sailing ships. Welcome to Everyday Origins. Today, we're uncovering the secret of the railway stones. To understand the stones, we first have to understand the problem. A loaded train is incredibly heavy. We're talking about millions of pounds of steel and cargo. If you placed that much weight directly onto the ground, the intense pressure would crush the soil. The tracks would sink and buckle, and eventually the train would derail. This is where the stones come in. Technically, they're called track ballast, and to understand how they work, think of the track as a layer cake. Steel rails sit on top. Those rails rest on horizontal beams called sleepers, or ties if you're in America, and the sleepers sit on the ballast. The job of the ballast is to act as a cushion. It takes the immense concentrated weight of a moving train and spreads it out over a wide area, dissipating the pressure so the ground underneath doesn't get crushed. But here's the fascinating part. The tracks are not actually fixed to the ground. If you look closely, you'll see they're essentially floating on the stones. They aren't bolted deep into the earth. They rely on friction in the sheer weight of the ballast to stay in place. That flexibility lets the track absorb the violent vibration of a roaring train rather than snapping under the tension. Now you might be thinking, okay, stones support the weight, but why these specific stones? Pick up a piece of track ballast and you'll notice something immediately. It hurts your hand. These stones are sharp, jagged, and brutally ugly. You will never see smooth, round pebbles on a railway track, and there's a very precise engineering reason why that is. Imagine stepping into a pit of ball bearings. You'd slip everywhere, right? Smooth stones do the same thing. They roll over each other. If a train ran over smooth, round rocks, those stones would roll away under the vibration, and the track would slide apart. Instead, engineers used crushed stone, usually granite or quartzite, smashed into sharp, angular shapes. When those jagged pieces are packed together, they don't roll, they interlock. Their sharp edges bite into each other, creating a solid, almost immovable mass that still allows just enough flexibility. Even when a high-speed train screams around a curve, the stones hold firm. And they don't just hold weight, they fight the two biggest enemies of the railway: water and weeds. If tracks were laid on a solid concrete slab or bare dirt, heavy rain would cause serious problems. Dirt turns to mud and washes away, leaving the track unsupported. Concrete creates puddles that rust the steel rails, but a bed of stones? It's perfectly porous, like a giant drain. When it rains, water flows instantly through the gaps and away from the track, keeping the ground dry and stable. Then there are the weeds. You rarely see a jungle growing in the middle of train tracks. That's because a thick layer of sharp rocks makes it nearly impossible for plants to root freely. And that matters. If roots were allowed to grow freely, they'd crack the soil and destroy the stable foundation the whole system depends on. So, the stones are a weight bearer, a drainage system, and a weed killer, all in one. But here's one last detail that might surprise you the most. Why do we call them ballast? That word actually comes from the sea.
Centuries ago, when empty wooden ships sailed out to collect cargo, they were too light to sail safely. They'd bob dangerously in the waves. To weigh them down, sailors filled the ship's hold with heavy stones. That stabilizing weight was called ballast. When those ships arrived at port and loaded up their goods, the stones were no longer needed. They were dumped on the shore. And early railway engineers, hunting for cheap, heavy material to stabilize their brand new tracks, looked at those piles of discarded ship stones and thought, perfect. They used the ship's ballast for the train tracks, and the name never left. So, the next time you pass a railway track, don't look at the train. Look down. Those rough, gray, ugly stones aren't an afterthought. They're a self-draining, weed-fighting, weight-bearing engineering marvel, one that started on the ocean, ended up on land, and has quietly kept the entire world moving for over 200 years. The most powerful machines in history, held in place by rocks. Sometimes the simplest answer is the smartest one. This is Everyday Origins. If this changed the way you see the world around you, hit that like button and subscribe, because the most fascinating stories aren't in textbooks, they're hiding in plain sight, just waiting for someone to look down.